All right. Oh, thanks again, everyone. We'll go ahead and get started with the main talk. Once again, my name is Daniel. I'm really excited to talk about Intro to CircuitPython. And we're going to have some fun learning about embedded development using Python. So first of all, what is an embedded system? So there's kind of like two main things. One is a computer, an embedded system itself, which has a processor, memory, and input-output. And it's normally like dedicated towards doing something, especially like mechanical or electrical systems. Often modern ones use a microcontroller to control something. And they're these kind of like all-in-one devices that have all the memory and the input-output on board. So that's like the input output would be like the pins you would hook up to some other device or an actuator or sensor or something. Microprocessors are a little bit more powerful. They were traditionally made by like, Intel or AMD or other companies, and they're like what's in your computer. So they're for general performance, and they often connect to a centralized bus and communicate with the rest of the, GPUs and stuff on your computer that way. And normally the memory is outboard. However, this kind of clear divide between a microcontroller and a microprocessor has started to get blurred. Often some of the newer devices have offboard memory or have lots of power compared to like what an 8-bit microcontroller used to be. And we'll kind of show some examples of that. This is this is like inside one of the chips we're going to be using, this Raspberry Pi Pico chip. And so we'll talk more about that as well. It looks kind of cool inside. Also, embedded development was traditionally done in C. So here's like a little bit of C code. You can see like, pulling up things and turning on LEDs. And often like you would use an 8-bit microcontroller from companies like Atmel, who had AVR and PIC. And you would write and program your microcontroller all in C code. You would also program through this in-systems programming method, which uses this serial peripheral interface to program. And then debugging of your code, you would use this JTAG, which is this on-chip debugger interface, allows you to debug the software that was running on it. So all of this stuff, this is like a development board by Atmel here. All this stuff required you to set up a lot of serial devices and JTAGs and get your microcontroller working and booting and all that type of stuff. And actually, I have like one of these SDK boards right here as well. You can see it's pretty complex with like serial ports and stuff you have to connect to, right? In 2005, 2006-ish, Arduino was developing Atmel circuit boards, and it was actually originally a university project to make it easier for people to program microcontrollers. And so they created, and this was a university in Italy. They created this Arduino, and they're these single board microcontrollers. You can see all these pins that are exposed on either side for the IO, and that allows you to plug in a board on top of this that could be like a specialty board to add LEDs or some type of functionality you add, and those are called shields. And then you could also connect like a breadboard next to it as well. This is a USB interface, so now we have USB. You can just plug in and start doing stuff. And they also added an Arduino programming language API on top of C, and also this purpose-built IDE. And this became like way easier than trying to like use an SDK and a development kit to like get programming. So this is like, an Arduino Uno, like in the picture. Those are still very popular and sold a lot, but they're definitely more focused on like the C programming side of things. So MicroPython, as you've noticed, we're continuing to kind of lower the barrier to getting into developing embedded things. And MicroPython is this lean and efficient implementation of Python. It's actually created during a Kickstarter by someone named Damien George, who is a physicist in Australia. and it includes a small subset of the Python standard library. So it's this really small version of Python, and it's optimized to run on microcontrollers. And so this allows MicroPython to run as C on a microcontroller, and then allow you to use Python directly on it, including kind of the REPL environment that you're used to with your normal programming, and not having to compile code and all that type of stuff. So you can write Python directly onto your embedded system now. Also, a company called Adafruit created CircuitPython. Adafruit's a company that's focused on beginners, education, getting started easily. And they have lots of like tutorials and projects you can build with the boards they sell. This lightsaber is one of those projects. It's 3D printed, and they give you all the schematics, give you all the directions, everything you need to know, so you can like build these little projects. It also tried to make it much easier to get started once again. So it uses a USB disk to allow you to write to. So you write your code to this USB disk. Once you save a file you're working on, it automatically reloads the software on your chip. And that allows you to get instant feedback without having to like recompile or reload stuff, right? It also has a consistent API across all the different boards. And there's lots of examples for all these projects online as well. So this is kind of like a fork of MicroPython, but the two have stayed very similar. It is about 95% MicroPython, and then this little like additional things that make it a little bit easier. So we're going to be focused on CircuitPython tonight, but you could also do many of the things we're doing. You could use MicroPython directly as well. Okay, one other thing I want to talk about, like making it easier and cheaper to get started with embedded, is Raspberry Pi. I think probably a lot of you are familiar with that, which is a single. Raspberry Pi itself is known for creating this single board computer. They're about like $35, and they run Linux. And yeah, they've sold millions and millions of them for all kinds of little projects. Raspberry Pi Pico is not that single board computer. It's actually a microcontroller board, and they developed their own chip called an RP2040 microcontroller. So instead of, we're talking like Arduino uses Atmel, AVR, for example. So they actually created their own chip. It's this dual core ARM Cortex M0 processor. It's got 256 or 264K of internal RAM, and you can have 16 megabytes of off-chip flash. As I said, it's starting to like blur the lines a little bit between like a microprocessor and microcontroller a little bit. It has this wide range of I/O. You see all these pins on the outside, including I2C and the serial peripheral interface and programmable I/O. And they're super cheap. You can buy one for $5. Which is amazing, because you're once again really lowering the bar to get started. You can buy a microcontroller with all this capabilities, all this horsepower for $5 and start using it with CircuitPython, which is cool. Okay, so I'm actually going to be demonstrating with a Adafruit board that's using the same chip as that Raspberry Pi Pico. This guy's a little bit more expensive. It's about $20. I work in the automotive area, and some like CAN stands for Controller Area Network, and it allows microcontrollers to communicate with each other through a twisted pair of wires. And so I bought this board because I'm interested in like playing around with CAN communication. And it's actually also used for other things, like race bicycles use CAN to communicate between like the shifter and the shifting mechanism to make the shifts happen even faster and stuff. So it is used, or robotics uses it and stuff. So it is used for other things as well. So this is that, once again, this RP2040, and it has this onboard CAN that can send and receive signals. So my demonstration today is going to be on that, but you could easily use that same thing. Raspberry Pi Pico would work just as good, or many other CircuitPython boards. Okay, so editor setup. There's a editor called Mu, which probably you may not have heard of before. It's this really simple code editor designed to work with embedded development. It's really easy to get started. It's really simple and it's cross-platform. We're going to be using that because it's really easy to get started with and get going. There's also this Visual Studio Code extension called CircuitPython. It's really cool. It has things you'd expect it from like an IDE, like autocomplete. It allows you to select what board. We'll talk more about like serial consoles, but those are built in, and library installation. However, the project hasn't got a new release in like 8 months. And so some of the recent boards, even the one I'm going to be demoing with, aren't supported unless you kind of do like your own manual hack to get the boards loaded. So instead of going through all that today, we'll focus on the Mu editor, but I just want to point out this project is really cool. And yeah, hopefully in the future it'll get updated even more and get even better. Because it's kind of nice being if you use Visual Studio Code for other programming, it's kind of nice being familiar with the same environment rather than getting like a different editor for embedded development. Okay, so how do you install CircuitPython? You can go to circuitpython.org/downloads, and you want to select or search for your board. There's 430 boards that it supports right now that you can download for. You actually download in this USB flashing format called with an extension UF2. It's actually originally from Microsoft, who created this flashing format. And it's like an installer packaged together. And if you drag it to a USB drive, it'll actually re-image the USB drive, which is pretty nice because you can just drag and drop things, which is awesome. To get into the bootloader to program it, for this board, we're going to have to hold down boot and then hit reset. And then after we hit reset and release it, you release boot, and that will get you there. Other boards, like this is a CircuitPython Express. You have to hit reset twice on it to get into the bootloader. So I think those are the two most popular ways, either this holding down boot when powering or the double reset. We're going to see a USB disk called RP2, and we're going to drag and drop that UF2 file on there. And when it finishes flashing the drive, then the disk should disappear. So why are we doing this? So this board doesn't come with CircuitPython installed. It has like a preloaded program that's not CircuitPython, just written in C or something, loaded, that flashes this NeoPixel and the LED, and that's what it starts with. So we have to install CircuitPython to it when we get it. Is there any questions so far? I'll take a quick pause.
Right, is there like an emulator or something we're downloading, or just like we have to buy the actual physical thing when we go to the site, CircuitPython?
I don't know of an emulator for Raspberry Pi Pico where you could like play with it virtually. That's actually a great question.
Yeah.
That sounds cool. I'm not sure. I'm going to be using a physical device. I'm not sure, to be honest, if something like that exists. That sounds like an awesome idea or an awesome thing if it doesn't exist. But if something like that doesn't exist, then I guess you're going to have to shell out the $5 and order a Raspberry Pi Pico or something. So
Yeah.
I like that idea though. I haven't heard of that, but that sounds cool if someone had like emulated a board on the computer that you could play with. Okay, so this is like the basics for programming Python. So as you would expect to get your board to do hello world, you print hello world just like you would with normal Python. So that's pretty easy. And I'll talk a little bit in a second, connecting to the serial console, how you would actually see it print hello world, because it's running it on the device, not on your computer, right? And then the next one is, how would you blink an LED? Just like other modules in Python, you can import things. And I guess one of the main modules here is the board. So Sorry about that. This is one of the main imports is the board that comes with it, and that's built into the standard library. And so you can see also there's a digital IO that's input port to be able to select the LED on the board. And what the board does is allow you to not have to, like type in some hex value for some LED you want to blink. You can say board.led and set it to that digital IO digital input out. And this is now the LED on the board. And then you can set the LED's direction by, with digital IO.direction.output, and that sets the direction of the LED as an output. The reason we're using this while loop is because if you didn't do that, you would run the program through once and then it would just exit and stop. So maybe your LED would blink like once or twice and then would just stop working, right? So the while true will run forever. And so what this does is turn on the LED value and equal to true, sleep for half a second, turn it off, and then sleep, and then it repeats. So it's turning on the LED for half a second, turning it off for half a second, pretty much forever. So it's just blinking the LED. All right, so we got an initial blinking LED. That's cool. I mentioned the serial console. This is what you click on, and we'll see this in a second in the Mu editor to get to it. And this allows us to interface with the running program. So if you print hello world, you would like to be able to see it, and you can see it sent back to you over this serial console. And also Python's really famous for this, the REPL, the read eval print loop, which allows you to directly, type in print hello and get immediate feedback on what that does. You can do that through the serial console as well. You can run a program in the REPL and get immediate feedback, but the program is actually running on the device, right? And printing back the feedback. Okay, one of the last things I want to talk about are libraries. To save space, the standard library for MicroPython and CircuitPython are very small. So you have this core standard library. That's pretty different than normal Python, where Python's batteries included and the standard library is huge and has everything built in, right? So it's really constrained to this core functionality. We saw some of those things, like we could import board and we could import like a timer and stuff like that. That's built in the standard library, but really anything else outside of some of that like core functionality, you have to add a library. And so there's a lib folder on the USB disk. And so you can download these libraries and drag them into the lib folder. There's also a special format called a .mpy instead of a .py, which we're used to. And it's actually a binary format that's been compiled down to save space. So you can like have these super optimized libraries and add them in. And that Adafruit provides these project bundles that includes the code and all the libraries you need to run something all together. And then you can just instead of trying to figure out where to download libraries yourselves, you can just kind of drag and drop them onto your device, which is cool. There's also a command line tool we could look at a little bit called CircUp. And it can be used to install and update libraries. So this is an example. We use pipx, which is a cool tool to install libraries in Python that you want to, not just for a project, but like computer-wide that you want available. And then you can do something like CircUp install NeoPixel, and it will install the library. What that's also nice for is you can use it it's called CircUp for update. So you can also like say, hey, I have all these libraries installed on my device. I want to go out and look if there's any updates to those libraries available. So that's nice as well. That VS Code CircuitPython extension I talked about has this capability built in as well. Here's one more example, and then we'll kind of do a live demo. So these boards have what's called a NeoPixel. So it's this color changing, very bright kind of LED. And so this is an example where we're importing a library called NeoPixel. It's not part of the standard library, but time and board are. And then we're doing something very similar. So we're calling that library, creating this NeoPixel, and once again, passing in board.neopixel. So CircuitPython has everything for this board mapped and knows, hey, there's a NeoPixel here, and it maps it for us. This sets the brightness. So 1 is the highest brightness, but we could lower the brightness if we wanted to down here, right? So this sets the pixel brightness, and then while true pixel fill. So we set, we pass in the color and RGB. So this is, so we're pretty much setting it to red, green, and blue in different steps, and then we're sleeping between them. So in this case, this NeoPixel will change colors from red to green to blue. Any questions about any of that so far, team? All right, I don't see anything in chat.
I have one question.
Yeah, go ahead.
Well, like the pixel, like it says pixel brightness. Is that like for a different pixel, or is it still the NeoPixel?
That is for the NeoPixel. So we named our, sorry, I go back in presentation. We named our NeoPixel that we created. This instantiated the NeoPixel, and we called it Pixel. And that's really to not, the name can't conflict with the imported name, right? So we need to call it something else, but you could have called it, I don't know, cool Pixel or whatever you like. So yeah.
Okay.
Or neo_pixel or something. Okay. So I'm going to also set up my camera here so you guys can see the device. All right, so this is that RP2040 device. You can see this is like the default. There's a LED flashing right here, and this is the NeoPixel moving right there. And there's also this, this is the boot button right here, this little one. And then this is the reset, the other one. And yeah, so that's what it looks like. You can see it's very, very small. It's plugged into a breadboard. If you get one of these, you don't necessarily have to put header pins on it and plug it into a breadboard like this. You could just, if you're not gonna use the IO or something like that, this is just allows you to like hook up other things to the board if you want to, right? Or interface it with stuff. Okay, so if you see my screen, there's no drive here, and we have the board, it's plugged in and going, and this is like the default program. So we need to get to the bootloader. So in order to do that, we hold down this boot button and then hit reset. I know it's pretty small. And then I'm letting go of boot. And you can see on my computer that this USB drive showed up. And so you can see there's some files in there from the original image that comes with the device, right? So we want to install CircuitPython. So I downloaded from that download site the image for this device. So it says Adafruit Feather RP2040 CAN. That's this device. And it's this UF2 file, which is the disk image that we talked about. I have some other ones here as well. If I want to, this is how I got it back to like the factory look with it unimaged. So you can reset it back to like the factory settings. But we want to install CircuitPython. So all we're going to do is drag this to our drive. This is a Mac OS, but it works the same in Windows as well. So it's copying the files and installing them now. And then we expect when it's done, it will eject the disk automatically. So it's just going to take a second. And not only did it eject the disk, it closed everything, right? So So the disk isn't here anymore, which is success. That's what we wanted. So I'm going to go ahead and like disconnect this, or we could hit the reset and plug it back in. And then our USB disk changed names for that RPI-RP2 or so now it's called CircuitPython. So that's what we wanted. And you can see on here by default, there's a code.py. It looks for that to run the program. It could also be called main.py or code.txt or main.txt. And then there's the lib folder, which is empty. That's where you'd put your libraries in. So the main thing we're going to be using is this code.py. So congrats. I mean, we've installed CircuitPython. That was all there was to it. So we have this device running CircuitPython. I also installed Mu Editor, so I'll go ahead and launch that, and then we can start some basic coding for our examples for the demo. Okay, so you can see it's use current mode of behavior CircuitPython. You can click on the mode and select which one you want, or maybe your first time loading it, it will ask you what this is. And we're using CircuitPython, so that's a mode we want to be in. And when we load the file, we want to open our USB drive there and load that code file. Mine's already open. And you can see the default program is just this hello world. Right, so we have hello world here. Now to be able to see anything from hello world, we can click on serial. And it says auto reload is on, simply save files over USB to run them or enter REPL to disable. So we could actually check out the REPL here. So this says Adafruit CircuitPython. So this is the actual Python running on the device. So we can say print hello Michigan Python. And it came back with a response from the device. So it printed out hello Michigan Python. So this is the serial connection. So that was pretty straightforward to use and get started. And this is like a full REPL. So we could, like type things like help board. And actually that was a string. I don't think I want I guess I have to import board probably. And then help board. I put board in quotes, which isn't right. So it was saying, oh, that's a string, which isn't what we wanted. So you can see like, hey, board LEDs, the buttons, these are all of the things that are on the board that you can interface with, NeoPixels, CAN, all that type of stuff. So this is also helpful for just like understanding what's available on the board. You can just run help directly. And this help is coming from the device itself, telling us what is available on the device. So that's kind of cool. And then you could get more information. So you could like, I don't know, help board.led or something like that. And it's telling us this is like type pin. So there's a pin associated with that, right? Okay, so that's the REPL. So we can hit now Control D to get out of that. And it says auto reload is on, and it said code.py output. So it reran the program and printed out hello world, which is what we expected. And I accidentally clicked back to the REPL again, but yeah, it got back to reloading the program, right? Okay, so we have like a simple hello world example. Maybe we could program our other things real quick. You also notice on here that there's nothing like blinking, or it's actually hard to tell that the device is on because there's no lights or anything, right? It's just like the device there. Okay, so if we wanted to, like our examples of like blinking an LED or something like that, we can import board, import digital IO, import time, and then we want to set the LED to the digital IO dot digital in out and set it to the board dot LED. So we're creating our LED. and then setting its direction. Nope, we want to set the direction. And then this is an output because LED is outputting light, right? And then we want that while true loop. And we want to set the value equal to true. And then we want to sleep for some amount of time. And then set to false. And then sleep again. Okay, so very simple program, but we can go ahead and click the save button. And it says saved. And it said like input output error. Not sure why, but okay, so it says auto reload is on. Sometimes I've seen these input output errors. Sometimes it helps to reboot it, right? But you can see now that this LED is blinking. Not super exciting, but we got a blinking LED doing what we wanted to on the program. Any questions about that so far?
We can't really see like your screen. It's kind of small.
The code's a little small. Is that better?
No, I'm talking about like your camera.
Oh,
Like, is there a way you could swap it with your screen share?
I don't have a way to swap my video with that, but I think you can in Zoom, you can change your settings to make me as the at least I don't think I can put myself as a spotlight for everyone. Does that work? Or not really?
Not really. It just kind of like moved it. Like, cause like there's a bunch of like other people on top and like it's been a while since I've used Zoom, so I don't know like how. Cause there's your screen share, the big one, and then like the Arduino, I can't really see it.
Yeah, so I think where the video is, you can change the setting from like a to a show active speaker video. I don't know, does that help you guys?
Yeah, I'm on a tablet though, so I don't know if that makes
Okay.
a difference. I just swipe right, and like you said, it shows a frame of just the camera, so I can see the light blinking from there.
Yeah, do you know those saying you can click on my image and pin it, select pin, and that will bring it up large. Yeah, sorry if the video is small for some of you. It is blinking though. Okay.
I see blinking.
Cool.
Okay, yeah, I made it bigger.
Cool. Awesome. Okay, we could also do the NeoPixel real fast. It's pretty simple. So most of this is the same. So we need board. Instead of digital IO, we want this to be NeoPixel. And then we want our pixel. And we set it to NeoPixel. Now remember for this NeoPixel, and actually
All right, I just figured out how to do it. If on the right-hand side, there's a view button. Want to swap video and shared screen. Becomes really large.
Cool. Yeah, thanks for
On
that.
the top right, there's a view. You click on that, but there's a swap video and shared screen.
Cool, thanks.
No problem.
So we're gonna do NeoPixel now. Now remember, this requires a library. So we're gonna have to install the library as well to get this to work. And actually we could try it without it, but we'll get an error, right? Maybe we don't need to try that, but it's gonna give you a library not found error, right? Because it's not on the device unless we load it. All right, so we're now filling our NeoPixel with color. maybe we could copy this. Paste it a couple times. Okay, so we have the 3 colors. Now the other thing we can do on this is to actually like grab the library. So the way this looks, this is like the website, right? So you can go into these examples and say, I want to download the project bundle, and I'll download the whole thing together as an example. And then what that looks like in my downloads here, we have this CircuitPython template, which is what it downloads in a zip file. We're using CircuitPython 8. You can see it also comes with a older version if you want. And what you can do is take this and just drag. See, it has these. Yeah, what it has in here is a library. So there's 2 libraries. There's a NeoPixel it needs, and that .mpy is a binary version of the Python that's optimized for the device, right? And then this Adafruit pixel buff .mpy, and then it has the updated code as well. We actually don't need the code because we just wrote it, so let's skip that part. So we can just drag then the library folder onto the CircuitPy. It says there's already one there, but that's okay, we'll replace it. Okay, so it loaded that, and if we go to the device, you can see those libraries are there. And if we go to here, we haven't saved it yet, but when we do save it, then we should be able to, use the device, right? All right, so let's force this to reload again. Okay, so it says auto reloaded. So if you can see now, this is maybe way easier to see than the last LED, right? But you have this NeoPixel that's flashing the 3 different colors. And so we created that. And we could, of course, like combine these and flash LED and the NeoPixel or something like that. So I know those are all like pretty straightforward examples, but I think they're useful for, hey, how do you load a library? How do you get parts of the device using this board.the device name, and be able to create a while true loop and start interacting with the device and loading stuff. That's pretty much what I wanted to go through for the demo. Is there any questions about any of that?
Dan, I have just a general question. What have you been using this for? Is it, do you have any like practical applications, or it's just a hobby? I'm curious.
So I have used controllers in the past for stuff like, in college, I developed like a actively damped motorcycle suspension that was using an Atmel. Yeah, remember that SDK and all that type of stuff. It was all using that in C, right? I've used Arduinos. I have a EVSC for charging my car, which is the like EV charger, and it's running on an Arduino. And I've also done like beer brewing with Arduinos before. For this specific device, I actually want to play around with the CAN interface and practice doing some like automotive type stuff, because I work at Ford and I'm interested in kind of being able to try using CAN and learn more about AutoSAR, which is an open standard for like automotive software. So that's what I want to use it for and play with it more. But yeah, in the past, I've created other projects for stuff, and I was showing my son that lightsaber, and he looked like he's like, "Oh yeah, let's get a 3D printer and make that or something." So, just kind of fun to play with.
So the CAN thing is interesting. So you're going to go off the ODB 2 port inside the car to get to the CAN. How are you going to do that?
So this is a CAN bus right here. This is like you connect wires to here, and it has an onboard CAN chip. So I wasn't necessarily planning on, we could, like try to connect this little guy up to my car or something through the OBD port. I wasn't planning on that. I was just planning on messing with it as is to communicate between boards and stuff like that.
Oh, okay.
But you could imagine like, oh, hey, if you want to, I don't know, try to do something to your car, or make some little project with your car. You could interface with a car as well.
Cool. All right. Thanks. So this other question is that what other plugins are there with this? Like, how would you connect the GPS or cellular modem to this? What other possibilities are there?
Like really common things are Bluetooth. I think you can get Wi-Fi as well. Bluetooth's really nice because like then you could do things like, hey, I'm putting this in my lightsaber and I want to update the code. You could actually update it over Bluetooth, stuff like that, and attach a battery to it. Yeah, I guess there's like hundreds of devices. So, anything from like the Circuit Playground Express has like temperature measurements, it has light sensors, it has switches. This is like a switch built in. It has all kinds of stuff. So you could like start like, I don't know, coming up with logic like if it is dark outside and this happens, then turn this on and stuff like that, right? So
All right.
depending on what you want to work on though, I'm sure like there's probably some type of device or breakout board or something to do to expand one of these boards to do whatever you want to interface with. So they're pretty cool for the amount of different options and things you could do with it. So all right, any other questions, anyone else been playing with? Go ahead.
How do you stop the the while loop? Are you gonna like put an if statement for anything?
Yeah, so if we could either use a different type of loop if we really don't want it to go forever. So we could, we could use a for loop and count up to something if we want to run it a certain amount of times. Or we could break out of it if something happens. That's possible as well. But normally if you want to break out of it, probably a while loop's not the best choice. But yeah, you could. But you could do like.
No, I'm talking.
Sorry, go ahead.
I'm talking about like for the while loop, you could use like maybe an if statement and have like an input. Is there like a button on there? On the Arduino?
Yeah, there is. So this button right here, you can access with a button. So if we want to do logic, like, hey, if this button's pressed, turn on the LED, we could definitely do that.
Yeah.
For sure.
Or like turn it off or break out the while loop.
Yep.
Okay.
Yeah, you could. You could definitely put logic in, like if this button's pressed or something like that, then stop blinking or something like that. Yep. The problem is if you break out of the main loop or something like that, then your program's done, right?
Yeah.
Not gonna do anything.
That's why I'm having like problems with that. Like with my code, I'm trying to make a while loop where I can like turn it off and turn it back on. I don't know how to do that. Like to access the while loop. Do I put it in a function or do I don't know. So it calls it back whenever it checks the state of like a button to see like if it's pressed or not.
I would recommend trying to keep the while loop as is and think of this as like the main loop in your program, the main thing that's always run over and over again. And then do things like add if statements or other loops underneath it, right? For logic.
Oh, okay.
because like I said, as soon as you break out of that, then your program's like dead. You have to like restart it,
Okay.
right? So I would keep this as the main loop of the program and then put all your logic underneath it. Yep.
Okay. Thanks.
Yeah, that's a good one. Thanks for asking that. Any other questions, anyone?
Then I could make it work using the MU editor, but using the VS Code, I'm receiving a error. I know that you shared about some script that is to run. Can you, not sure if you can show more details how to do it, because I could not run the script to make it work in VS Code.
Yeah, I like that. Maybe let's do that after we stop recording and everyone's got their questions answered, and anyone who's interested in staying and seeing how VS Code works, we can stay on for that. Does that sound good?
Yeah, sounds good.
Cool. Thanks, Junilo. Any other questions, anyone? Everyone
Hey,
excited
Dan.
about getting a device? Hey.
Hey, I may have missed it, but was this for just a certain line of boards, or can you program all sorts of microcontrollers with this?
So I was showing like a specific board, but CircuitPython runs on 430 different boards. So it's pretty diverse, even it's focused on definitely boards Adafruit provides, but like it supports
Okay.
lots of other boards too, right? You can get Raspberry Pi Picos, you can get all kinds of stuff, right? So there's a lot. And one nice thing about this is these programs you made are really independent of the board being used. So if your board has a NeoPixel, it maps everything for you in this board.neopixel. You don't have to worry about like reconfiguring it or something, right? So
Right, okay. Yeah, I program an STM32 for my part-time job at the university, so it's all C, and it is, you know how much of a hassle it is to go through the data sheets all the time, anytime you want to do anything.
yeah.
This
Just
is
getting
so
like
much
started,
easier.
just getting a hello world is like,
Yeah.
oh God, this is going to take me a few hours.
I gotta make sure the clocks are configured the right way. I gotta check for under all sorts of stuff.
Yeah. Kind of
Okay.
fun, but if you just want to build something, it's like, oh, do we really want to do all that? So yeah.
It is fun. But then when you have to report to the rest of the team and you're like, oh, here's it working, it's nerve-wracking.
Yeah. No, that's cool. Yeah, you could. I think you could definitely use some type of STM32 stuff with MicroPython, I'm sure. So
Yeah, I might look into it.
cool. Awesome. Thanks, Jay. Everyone else excited about going and trying some CircuitPython on something? Halloween's right around the corner. You could get like a CircuitPython Express and have cool flame effect inside your pumpkin or something. Yeah, there's an idea for you could get one of these guys and make a flame in your pumpkin.
I dig it.
Yeah,